This is the study guide for the Chapter 5 Geometry test. We're going to begin by creating a Venn diagram out of a statement and using that Venn diagram to reach conclusions. So we have the statement that all squares have four equal sides. So what we're going to do, is we're going to draw a big circle with a little circle in it. If we were to write this as a biconditional, we would say if it is a square, and so square would be our little circle, then it will have four equal sides. That would be the conclusion part. Given that it's a square, it has four equal sides. Now, we want to be able to answer questions based on any of that, though. If it's a square, what's true? If it has four equal sides, what's true? If it's not a square, what's true? If it doesn't have four equal sides, what's true? So what can we conclude if it is a square, given that it is a square? What can we conclude given that it is not a square? What can we conclude given that it has four equal sides? What can we conclude given that it does not have four equal sides? See? Now, all squares have four equal sides is true because that's part of the definition of a square. A square has four equal sides and four right angles. So let's say that we're given that the figure is a square. So what we would do if the figure is a square, it's got to be in the little circle. So we could represent many things that are squares by putting many dots in the little circle. But to be a square, it's got to be in the little circle. So what can we conclude about four equal sides? Well, every single dot that's in that little circle is also in the big circle, which means we can conclude about every single one of those things that they have four equal sides. Well, then we would say, well, what if it says not a square? Well, we're going to redraw this thing. Four equal sides. Square. Well, it says the figure's not a square. Well, not a square means it's not in the little circle. If it's not in the little circle, then it could be in the big circle, but it doesn't have to be. It could be outside the big circle. So if it is not a square, then it might have four equal sides, but yet then again, it might not have four equal sides. And so we can reach no conclusion as to whether it has four equal sides or not, just given the fact that it's not a square. Something that does have four equal sides that's not a square is a rhombus, a humpy-jawed square, see. But then you could have something that doesn't have four equal sides, nor does it have, nor is it a square, you see. Okay. Uh, a figure has four equal sides. Well, we got to start with our Venn diagram again. Four equal sides, square. If it has four equal sides, then it's in the big circle. Now, it could be in the big circle, but not in the little circle, but it could also be in the big circle and in the little circle. So if it has four equal sides, it might be a square, but yet then again, it might not be a square. So we can reach no conclusion as to whether it is a square or not, just given the fact that it has 4 equal sides. All right. Well, here we go again. This time it says it does not have 4 equal sides. Now, if it does not have 4 equal sides, then it has to be outside the big circle. Now, if it's outside the big circle, there's no way it can be inside the little circle. So if it does not have 4 equal sides, we can reach a conclusion, and the conclusion is that it is not a square. Any questions on taking a given statement, creating a Venn diagram, and answering the question, if it is this, can we conclude that? Or if it is not this, can we conclude that? Okay? Now, the next thing we're dealing with is inequalities in a triangle. And we know that if all of the angles of a triangle are equal, then all the sides are equal. Or if all the sides of a triangle are equal, all the angles are equal. In other words, all equal angular triangles are also equilateral. Or if a triangle is equilateral, it's also equiangular. We also know in an isosceles triangle, if two sides of a triangle are equal, then the angles opposite those equal sides are equal. Or if two angles of a triangle are equal, then the sides opposite those equal angles are equal. Well, just like that is true, it's also true that in a triangle, side opposite the largest angle is the largest side. The side opposite the medium-sized angle is the medium-sized side. And the side opposite the smallest angle is the smallest side. So we want to name the large, medium, and small side. And again, in this text, I'm making you learn fractions and decimals. So you can't compare an eighth to a 0.12 unless you change both of them to fractions or both of them to decimals. We're just going to change the fraction parts to a decimal. Now to do that, you do what it says, 1 divide 8. Now it won't go, so you'd add a decimal and a 0, and then 8 goes into 10 one time, so you get 8 with 2 left over, and then you'd add a 0 and bring it down. And then 2 goes into 8 16 times, and you'd have 4 left over, and you'd add a 0 and bring it down. Then 8 goes into 45 times, and 5 times 8 is 40. And so 1/8 is 0.125. 1/8 is 0.125. And so 8 and 1/8 is the same as 8.125. 1/5. If we take 1/5 and make a decimal, we take the 1 divide 5. It won't go, so we add a decimal and a 0. 5 will go into 10 2 times. 2 times 5 is 10 with 0 left over, and so this is 8.2. Now, if we wanted to compare, then we would add enough zeros to make them all the same, have the same number of decimal places. So that's 1 2 0, and this would be 2 0 0. And so we have 2 8 and 200 thousandths. It's in the third place over the thousandths place, as compared to 120 thousandths, as compared to 125 thousandths, the most being the 200, so this is the largest side. The medium amount being the 125, so this is the medium-sized side. And the smallest being the 120, so this is the smallest side. Now, the largest angle is opposite the largest side, so the largest angle is angle B. The medium size angle is opposite the medium size side, and so the medium size angle is angle C. And the smallest angle is opposite the smallest side, so the smallest angle is angle A. Any questions on that? Okay. Conversely, the largest side will be opposite the largest angle, so the largest side is side AC. The medium size side will be opposite the medium size angle, and the medium size side is BC. The smallest side will be opposite the smallest angle, and so the smallest side is side AB. Any questions on that? Okay. That was inequalities in a triangle. Now we're going to be dealing with inequalities in two triangles. And again, the way I visualize this is having a compass open up or close. Okay. As you're visualizing the two equal sides and the third side and the angle, as you open your compass up bigger, that bigger angle, you're going to have a larger side across from it. So if two sides of one triangle equal two sides of another, then the one with the larger third side will have the larger included angle. If we add zeros to compare our decimal, then this is 6 and 200 thousandths. This is 6 and 187 thousandths. 200 thousandths is bigger. This is bigger, so the angle included is bigger. If two sides of one triangle equal two sides of another, then the larger third side has the larger included angle, so angle 1 is larger than angle 2. Again, given that two sides of one triangle equal two sides of another, this triangle with the larger third side will have the larger included angle. And we're going to have to compare as decimals, so we're going to take that 3 fraction bar means divide 8. It won't go, so we add a decimal and a 0. 3 eighths are 24. With 6 left over, add a 0, bring it down. 7 eighths are 56. With 4 left over, add a 0, bring it down. 5 times 8 is 40. 0.375. So we have 4.375 compared to 4.400. This one is 400 thousandths. This is 375 thousandths. 400 thousandths is bigger. This has the larger third side. Therefore, it have the larger included angle. Therefore, angle 2 is the larger of angle 1 and angle 2. Now, the other references the third side being larger if the included angle is larger. So here we go. If two sides of one triangle equal two sides of another, then the triangle with the larger included angle will have the larger third side. Therefore, AB is the larger in that situation. if two sides of one triangle equal two sides, we don't know that two sides are equal. Therefore, we can reach no conclusion. And I did this on purpose because sometimes what people do is they just say, if it looks like this, you do this. Well, you can't just make conclusions if the if part is not true. If this is true, then we reach this conclusion. If two sides of one triangle equal two sides of another, then. If you're not given that two sides of one is equal to two sides of another, you can make no conclusion like we did on 12, 13, and 14. See, you always have to make sure that the if part is true before you go trying to reach a conclusion. All right. 16 through 19 says, tell whether the links can form a triangle. Now, to be a triangle, the sum of the smaller two must be greater than the large. So what we're going to do is check it out like this. Small plus small must be greater than large to be a triangle. So we're going to check out small plus small. 3 1/2 plus 4 1/4. And we're going to compare that to 7 7/8. Now to do that, we would need to get a common denominator of 8s. Take that 3 1/2 and that 4 1/4, and we would need to be adding, but we would need it to have that common denominator 8 if we can, and we can. So we would make equivalent fractions by multiplying by whatever it takes. So we think 2 times what is 8? 4. So 1 times 4 is 4. 4 times what is 8? 2. So 1 times 2 is 2. So 4 eighths plus 2 eighths is 6 eighths. 3 plus 4 is 7. We have 7 and 6 eighths. This was 7 and 7 eighths. I realize the 6 eighths are reduced, but we're wanting to be able to compare. 6 eighths is less than, not greater than. The sum of the smaller two is not greater than the third side. Therefore, this is no triangle. Okay? Again, we're trying to see if small plus small comes out to be greater than large. If it does, it is a triangle. So we're going to take the small plus the small here, 8.3. We're going to add 9.04. We get 17.34. If we lined up our decimals there, added a 0 as a placeholder, 17.34. We're comparing that to 17.298. To compare, we'd put a 0. This is 17 and 340 thousandths as compared to 17 and 298 thousandths. 340 thousandths is bigger. Small plus small is greater than large. Therefore, it is a triangle. Yes, it is. Okay. Is that a triangle? Yes, it's equilateral, but we can check it out. Small 3 plus small 3, 6, 3. The sum of the smaller two is greater than the larger, so yes, it is a triangle, and we knew it was to begin with. It's an equilateral triangle. On number 19, we may just change these fractions to decimals. 1/4 is 0.25. You could take the 1 divide 4. and 3/4 is 0.75. You could take the 3 divide 4. So what we have is 3 1/4 or 3.25. We're going to add to that 6.4, the sum of the smaller two, and we'd put a 0 as a placeholder and get a 5 and a 6 and 9. And we're comparing that to 10 3/4 or 10.75. It is less than, not greater than, so this is not a triangle. Any questions on 16 through 19? To be a triangle, the sum of the smaller two sides must be greater than the length of the third side. Okay? Number 20, we want to name an altitude. An altitude is a segment from a vertex perpendicular to the line that contains the opposite side. Here's a vertex. This is the line that contains the opposite side, QI. An altitude is from a vertex perpendicular to the line that contains the opposite side. So segment FE is an altitude in that triangle. It is a segment from a vertex perpendicular to the line that contains the opposite side. A perpendicular bisector. Bisector of a segment, or the bisector of a segment, is a point that divides a segment into two equal segments. H is obviously the midpoint. Therefore, RH is a bisector. But it's not the only bisector. IX is a bisector. So we got two bisectors. But we don't want a bisector. We want a perpendicular bisector, which means not only does it hit the midpoint, it also hits at 90, and the only one of those that does both is RH. RH is a perpendicular bisector of QI. Any questions on that? Name a median. A median is a segment from a vertex to the midpoint of the opposite side. X is the midpoint of the side opposite point I. A segment from a vertex to the midpoint of the opposite side is called a median. So IX is a median. Name the distance from the point to the line. The distance from a point to a line is defined to be the length of the perpendicular segment drawn from the point to the line. We want the distance from point R to QI. The distance is the shortest distance, and the shortest distance is straight down or perpendicular. The distance from a point to a line is defined to be the length of the perpendicular segment drawn from the point to the line, and we represent length without any symbol above it. Just RH represents the distance from point R to point H. Distance being a value, not a segment, you see. Okay? All right. Next picture. Since H lies on the what? That's a midpoint, which means that XH bisects it, and it's perpendicular. So XH is a bisector, and it's perpendicular. So it's a perpendicular bisector. Point H lies on the perpendicular bisector. Of the segment. There's a little theorem that says if a point lies on the perpendicular bisector of a segment, then that point must be equidistant from the endpoints of the segment. That looks just like the isosceles triangle theorem, doesn't it? Which would obviously prove it. And so segment HA, or the distance from H to A, is equal to segment HP, or is equal to the distance from H to P. Okay? A point that lies on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. Next picture, number 25. Since point S lies on the what? Well, ray AS bisects angle EAU. So point S is the point that lies on the bisector of the angle. A point that lies on the bisector of an angle is equidistant from the sides of the angle, so the distance from S to side AE, which is that perpendicular distance, is equal to the distance from S to side AU, which is that perpendicular distance. So this distance is equal to this distance. So SE is equal to SU. Oh, S is equidistant from the sides. Ray AE. Remember, an angle is a figure formed by two rays with a common endpoint. The two rays are called the sides. The common endpoint is called the vertex. So when you name the sides of an angle, you have to name them rays, ray AE and ray AU. If a point lies on the bisector of angle, it's equidistant from the sides of the angle. Therefore, this distance ES is equal to this distance US. Okay? Name three equal segments and tell why they're equal. When you look at the little mark 90, then that tells us we have a perpendicular bisector of a side. So here we have a mark, two marks, 90. Therefore, we have the perpendicular bisector of the side. We have three marks, 90. Therefore, we have the perpendicular bisector of the sides. The perpendicular bisectors of the sides of a triangle intersect at a point that is equidistant from the vertices of the triangle. That point is called the circumcenter. So that point of concurrency is equidistant from the vertices. So HA is equal to HE, which is equal to HI, because the perpendicular bisectors of the sides of a triangle intersect at a point equidistant from the vertices of the triangle. It didn't ask us, but if we use that point of concurrency as the center, and we used one of those distances we spoke of as a radius, we could circumscribe a circle, and I got kind of crazy at the bottom. We could circumscribe a circle about that triangle, and therefore that point is actually called the circumcenter. Okay? Number 27. Number 27, what we have given are angle bisectors. An angle bisector is a ray that divides an angle into two equal angles. So that was an angle bisector. Here we have the bisector of the original angle K. Can't name it that now because there's more than one there. This would be the bisector of the angle at H. The bisectors of the angles of a triangle intersect at a point that is equidistant from the vertices of the triangle, of the sides of the triangle, excuse me. So the distance from A to this side, which is that perpendicular distance, is equal to the distance from A to this side, which is that perpendicular distance, which is equal to the distance from A to this side, which is that perpendicular distance. Okay? So segment AG is equal to segment AR, which is equal to segment AI. You couldn't see the I here. Segment AG is equal to segment AR, which is equal to segment AI, because the bisectors of the angles of a triangle intersect at a point equidistant from the sides of the triangle. The bisectors of the angles of a triangle intersect at a point that is equidistant from the sides of the triangle. And again, if we used that point of concurrency as the center and one of those distances as the radius, we could inscribe a circle in that triangle. The circle would be said to be inscribed in the circle, and the triangle would be said to be circumscribed about the circle. Okay? Normally, we like the word circumscribe to be a circle. It could still represent a polygon that was drawn around or outside of a circle. Okay? Next picture, JA. JA. Now, we need some given information, and it didn't say the given information. But what we were assuming here, and the marks weren't there, is that these are medians. So it should have been given that P is the midpoint of this side, making JP a median. H is the midpoint of this side, making FH a median. I is the midpoint of this side, making BI a median. The medians of a triangle intersect at a point 2/3 of the distance from a vertex to the midpoint of the opposite side, or such that the big piece is twice the little piece. They're in a ratio of 2 to 1. Or the big piece is 2/3 of the whole thing and the little piece is 1/3 of the whole thing. If this little piece is 3, then its big piece is 6. If IB, this whole thing, is 7.4, then IA is a third of that. So we would have to take 7.4 divided by 3. 3 goes into 7 2 times. You get 6 with 1 left over. Bring down a 4. Excuse me. 3 goes into 14. And my decimal is going to be there. But 3 goes into 14 4 times. You're going to get 12 with 2 left over. And then you're going to add a 0 and bring it down. And so 3 goes into 26 times. And you get 18 with 2 left over. And as soon as we see that 2 again, we know there's a repeating 6. So that's 2.4666666666666. But we don't accept repeating decimal answers. That means we need to back up and write it as a fraction so that we don't round. We have exact answers. So where is it that we ran into that decimal? Well, let's backtrack a little bit. I should have just kept it, but let's do that again. We have 7.4 divided by 3. It went 1 time, and we get 6. It went 2 times, excuse me. You get 6 with 1.4 left over. You put your remainder 1.4 over your divisor 3. So we actually have this 2 and 1.4 thirds, but we don't leave a decimal in a ratio. It tells you that you can't have a decimal in a ratio on page 51 of the Algebra 1 text. What you do to fix that is you move your decimal 1 and you move your decimal 1. So now we have 2 and 14/30. And then we reduce by dividing by the greatest common factor 2. And so we get 2 and 7/15 millimeters. Whoops, that's centimeters. Aha. A lot of fun here, huh? So we have 2 and 7/15 centimeters. And we want to change that to millimeters. There's 10 millimeters in a centimeter. And so we would actually multiply that by 10. Now, we could make that improper and we could multiply it by 10. Or we could go back to our division and take a look at it again. Let's just multiply this by 10. How do you multiply that by 10? Well, you make it improper. 2 times 15 is 30 plus 7 is 37 of those little 15ths. To multiply it by 10, you put 10 over 1. 5 goes into 10 twice. 5 goes into 15 3 times. You multiply 37 times 2 is 74. 3 times 1 is 3, so we get 74 thirds. If you want to make a mixed numeral, you would take 74 divided by 3. It'll go 2 times, you get 6 with 1 left over, bring down a 4. 3 goes into 14 4 times, you get 12 with 2 left over. You put your remainder 2 over your divisor 3, and so it's 24 and 2/3 millimeters written as an exact answer. Any questions on that? So one of the things I did, I wrote this book. I put a bunch of nearly everything was whole numbers. I realized my students didn't know how to perform fractions and decimals on paper, so I went back and changed numbers to fractions and decimals so we would have to learn how to do that. I realize there's technology out there these days that will crunch all that out, but we still need to know how to do these things mechanically on paper. It's going to help us as we progress into factoring and other type things as we move into more advanced mathematics. Now, AB, the longer piece, is twice that shorter piece. The long piece AB is twice that. So we're going to make it improper. 3 times 24 is 72. Plus 2 is 74 of those little thirds. And then we need to double that because the big piece is twice the little piece. And so now we have 148 thirds. We take the 148 divided by 3. 3 fours are 12 with 2 left over, bring down an 8. 3 times 9 is 27 with 1 left over. You put your remainder 1 over your divisor 3. And so we have 49 and 1/3 millimeters. I'm having trouble with my pen writing where I want it to. 49 and 1/3 millimeters. Okay. Any questions on that? Okay. That's a 49 and 1/3. I'm going to write it one more time just so we get it in there right. 49 and 1/3 millimeters. Okay. All right, number 30. Number 30, FH. That's the whole thing is 3 1/4 inches, and we want FA. FA is 2/3 of 3 1/4. 3 times 4 is 12 plus 1 is 13/4. We want 2/3 of 13/4. 2 goes into 2 once, 2 goes into 4 twice. We multiply what's left. 1 times 13 is 13. 3 times 2 is 6. We take the numerator 13 divided by the denominator 6. It'll go 2 times. You get 12 with 1 left over. You put your remainder 1 over your divisor 6. And we have 2 1/6 inches for FA. It was 2/3 of the other one. AH is half of that. The little piece is 1/2 the big piece. So we want to take 1/2 of means times this 2 times 6 is 12 plus 1 is 13 of those little sixths. We multiply the numbers, numerators, and you multiply the names, denominators, and you get a new name. We'll take the 13, divide, that's what it says, 12. It'll go one time, you get 12 with 1 left over. You put your remainder 1 over your divisor, 12. And so we have 1 1/12 inches. Any questions on 28, 29, 30? Again, it should have been given that those medians, the medians intersect at a point so that the big piece is 2/3 and the little piece is 1/3. That point A is 2/3 of the distance from a vertex to the midpoint of the opposite side. That point A is called the centroid. The centroid. The medians are concurrent at a point, and the name of that point is the centroid. Okay. Draw and label the following. It says in acute triangle EFH, EF is 3 1/2 centimeters. So you'd get your ruler and you'd measure 1, 2, 3 1/2 centimeters, which this isn't to scale. 3 1/2 centimeters is centimeters the width of your thumbnail. So you'd get that measured out exact. Label it as EF. You would measure the angle E at 50, so you'd set your protractor here, find 50, draw an angle. Then you'd do angle F, so you'd set your protractor there. You would find 60 this direction. The point where those two hit would be your other vertex H, so you'd have triangle EHF. It would be an acute triangle with E being 50, F being 60, and H being 70. You would draw altitudes EA, FB, and IH. So EA would go from E to the midpoint. Here you'd have to find the, you want an altitude, I'm sorry. So it would have to go from here and hit at 90. And that would be point A. HI would go from H, hit the other side at 90. You'd call that point I. FB would go from here and hit that side at 90. And they would be concurrent. Now let's talk about how to make it hit from a vertex to hitting a side at 90. Now, what I would do to make that happen, there's a couple of things you can do. You could take your protractor and the little dot and the 90 and a ruler, and you could set that ruler there and you could slide it until that hits that dot and put a mark and mark it. Now that's using your protractor and a ruler and sliding across until you line it up. The official way to do it with a compass, that's that pointy thing with the pencil, would be to open up your compass with your pointy thing there and your pencil here, so that your pencil opens up to, that's not a good picture. So that your compass opens up to longer than straight down, but not so far that you miss. And then you would make an arc. So it can't be so long that you miss those other two vertices. And then you would open up your compass again from here with your little pointy thing and your pencil over halfway. And you would kind of, it wouldn't be setting like that. It'd be setting kind of sideways. And you would make an arc. And then you would come from here and you do the same thing and you'd make an arc. And where those two arcs meet, it should be a perpendicular that goes through there. That was kind of a crazy looking drawing, okay? I prefer to just take my compass, my protractor, excuse me, find 90, set my ruler there, slide that way or whatever until it hits the dot, and then you've got your altitude coming down at 90, okay? And you do that for each side. All right, number 32. Obtuse triangle XRE, 1 7/8. RE is 1 1/4. We're going to draw the medians. We're going to leave that one for you to investigate, maybe get some teacher help with. And then